Hello everyone. Our next topic is distance formula. So this topic is the last chapter of the unit coordinate geometry, and you will see that the concept which we have learned in the chapter in the topic of coordinate geometry is you can say it's put to application over here. So this is an application of coordinate geometry. Okay, so what is actually a distance formula? Distance formula applies to two points in a Cartesian plane whose coordinates are known x1 y1 and x2 y2. If you know the coordinates of 2 points in a Cartesian plane, suppose the points are A and B, you can find the distance AB. Okay, so what they have given, you see, for any two known given points in a coordinate or Cartesian plane, the knowledge of coordinate geometry may be used to find the distance between the two given points. The coordinates of a point which divides the line joining the given points in a given ratio. That is section formula which you will learn in class 10. The coordinates of the midpoints of the line segment joining two given points, again in class 10th. Equation of a straight line through the given points in class 10th, and equation of a perpendicular bisector of a line segment. Okay, so out of all these uses of coordinate geometry, we are going to focus on the first use, that is the distance between two given points. So what is the distance formula? Let's see. So let's say that we have 2 points on our Cartesian plane, A x1 y1 and B x2 y2. Do you see A and B over here? So it is clear from the adjoining figure that in the right angle triangle ABC, AC is x2 minus x1. What is AC? AC is the distance between points A and point C. Okay, and points A and C, the horizontal distance between them is the difference of their x coordinates, which is x2 minus x1. What about BC? BC is the vertical distance between B and C, which is the difference of their y coordinates, that is y2 minus y1. So if we know BC and if we know AC, can we find AB? By Pythagoras theorem, AB square is equal to AC square plus BC square. That is, AB square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So AB becomes under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, so you can also write it as, see, you had got the original formula as under root of x2 minus x1 the whole square plus y2 minus y1 the whole square as x2 minus x1, and x1 minus x2 does not make any difference since we are just squaring that difference. Okay, so it does not make any change to the final answer. So you can write x2 minus x1 as x1 minus x2 also, because after all you are squaring that difference. So even if that difference is negative, it is going to become positive. If it is positive, it will remain positive after squaring. So the distance formula becomes under root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Or you can say it under root of difference of abscissae the whole square plus difference of ordinates the whole square. Okay. In coordinate geometry, all the formula are obtained by taking the points in the first quadrant. But every formula will remain same or true in whatever quadrants the point may lie. Only proper signs must be used with the coordinates. So in this example, you might feel that they have taken the first quadrant and derived the formula. See, you can derive the formula for any quadrant. The formula will remain the same. Let's start with the first problem. Find the distance between points 3, 6 and 0, 2. Okay, let's make some space. Okay, so the first example says that you have to find the distance between the points 3, 6 and 0, 2. These are your 2 points. This is point A and this is point B. 3,6 and 0, right? You have to find the distance between point A and B, that is AB. Okay, so we can imagine that this 3 is x1 and this 6 is y1. Why? Because this point A is the first point and this point B is the second point. So this 0 is x2 and this 2 is y2. No need to show it like this. I am just showing you for your clarity. Okay, so distance between points A and B is under root of x1 minus x2 the whole square. Remember, I'm not writing x2 minus x1 because it does not make any difference. Okay, the value still remains the same, plus y1 minus y2 the whole square. That is the distance. Simply you have to apply the formula, put in the values. What is x1 minus x2? x1 is 3, x2 is 0. 3 minus 0 the whole square. Can you see x1 is 3, x2 is 0? Plus, don't make any silly mistake over here. You can actually. y1 minus y2 the whole square. That is 6 minus 2 the whole square. So AB is equal to under root of 3 minus 0, 3 square, plus 6 minus 2, 4 square. So AB is equal to 3 square is 9 and 4 square is 16. So AB is equal to root 25, which is 5 units. Since distance is measured in centimeters or meters and here no units are given to us, so you can write 5 units. So this is how you use distance formula. Very easy, right? Sure. Let's go to the next question. Okay, before going to next question, I want you to note down one thing. If one of the point is origin and you have to find the distance of any other point from the origin, then the formula, distance formula, becomes under root of x minus 0 the whole square plus y minus 0 the whole square. That is under root of x square plus y square. Very simple. And the next question is based on that. I'm going to do only one, that is the second one. If you want, you can do the first one. Find the distance between origin and the point minus 12 comma 5. You can do this. You can pause the video and try this. I will do the second one. Find the distance between origin and the point 15 comma minus 8. Now, here they have asked you to find the distance between this point and origin. Here they are asking you to find the distance between origin and that point. Does not make any difference. Suppose there are 2 points. Suppose there are 2 points, point A and point B. And if I tell you to find the distance between A and B or B and A, will it make any difference? Absolutely not. So which is x1, which is y1, which is x2, which is y2 does not make any difference. x1, y1 and x2, y2 are arbitrary. You can take any point as x1, y1 and any point as x2, y2. And distance from one point to other is the same as the distance of that second point with respect to the first one. Okay, so let's find the distance between origin and the point 15 comma minus 8. Okay, so the first point is origin and the second point is 15 comma minus 8. Okay, and as I told you, the distance between origin and in any point is equal to under root of x square plus y square. Under root of x square plus y square. Okay, so let origin be point O and this point be P. So OP is equal to under root of x square plus y square, because 15 minus 0 will remain 15, minus 8 minus 0 will remain minus 8. So this will become 15 minus 0 the whole square plus minus 8. Hey, why am I writing 15 minus 0? There is no need. I can directly write 15 square plus minus 8 square. 15 square is 225 plus 64. That is under root of 289, which is 17 units. Very easy, right? So the first one also you would have got it if you would have tried it. Let's check the answer. The answer of the first one is 13 and the second one is 17. Okay, there is one more suggestion they are giving you over here. Remember, I want you to take a note of all these things, because while you do the exercise, you shouldn't feel that okay, ये तो सर ने बताया ही नहीं. जो भी तुम्हारे exercise में जो भी type के questions है, all the details are given in solved examples. If you do all the solved examples, or if you watch me doing all the solved examples, you will have complete idea about how the chapter goes. Okay, so don't bother about that. Okay, if a point lies on x-axis, its ordinate is 0. Therefore, a point on the x-axis is taken as x comma 0, such as 3 comma 0, minus 5 comma 0, etc. We know that already from the coordinate geometry. In the same way, if the point lies on y-axis, its abscissa is 0. Therefore, a point on the y-axis is taken as 0 comma y, such as 0 comma 4, 0 comma minus 7. Perfectly fine. What is the third question? Find the coordinates of the point on the x-axis which are at a distance of 5 units from the point 6 comma minus 3. So what information do we have? We know that the point whose coordinates are to be found is located on the x-axis, and the distance of this point is 5 units from another point 6 comma minus 3. Okay, let's note it down. So I will write like this. Let the point on x-axis be x comma 0. We just read before this question that any point, any arbitrary point on x-axis is always of the form x comma 0. We have to find this point. Okay, the distance of this point, distance of this point is equal to 5 units. From which point? Another point. So the first point is on x-axis, x comma 0. Another point is 6 comma 3, 6 comma minus 3. So from 6 comma minus 3, the distance of x comma 0 is 5 units. Okay, let's put this in the formula and find the answer. So let this point be A. Let this point be A and this point be B. So the distance AB is equal to under root of x minus 6 the whole square plus 0 minus minus 3 the whole square. Okay, 0 minus minus 3 the whole square and x minus 6 the whole square, the sum of them. AB is 5 units, so this is 5. Okay, x minus 6 the whole square. Should we expand it? Okay, let's expand it. So we get x square plus 2 into x into 6, that is 12x. I think it is minus 12x because x minus 6 the whole square. So x minus 12x plus 36. Okay, so this will be 0 minus minus 3, which is plus 3. 3 square is 9. So this will be plus 9. Okay, now you can do squaring both the sides. So if you do squaring both the sides, what do you get? 5 square is equal to 5 square is equal to, the root will be gone because you are squaring both the sides, so root will get cut. So you get x square minus 12x, 36 plus 9 is 45. This is 25. Let's take it to the other side, so it will become x square minus 12x plus 45 minus 25. So we can say that x square minus 12x plus 20 is equal to 0. Now I have to find the factors of plus 20 such that its sum or difference will become minus 12. So 10 twos is 20 and I want minus 12. So minus 10 minus 2. Minus 10 minus 2 is minus 12 and minus 10 multiplied by minus 2 is plus 20. So x square minus 10x minus 2x plus 20 is equal to 0. So x bracket x minus 10 minus 2 bracket x minus 10 is equal to 0. Okay, so x minus 10 will come out common and x minus 2 will remain outside. So x minus 10 bracket x minus 2 is equal to 0. You know what I'm doing? I'm doing splitting the middle term, and this equation which you see over here is the quadratic equation. This equation is known as quadratic equation. So I'm solving this quadratic equation with the help of splitting the middle term, okay, which you would have understood. So how to solve this further? So I've got x minus 10, x minus 2, this is factorized, and this is equal to 0. See, product of two brackets is equal to 0. That means one of the bracket must be 0. So how do you write this? You write it like this. Therefore, x minus 10 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to 10 or x is equal to 2. So we have got two values of x, 10 and 2, and it happens sometimes. Okay, so how do you write your final answer? Therefore, the points on x-axis whose distance from 6 comma minus 3 is 5 units are 10 comma 0 and 2 comma 0. There are 2 points on x-axis whose distance from 6 comma minus 3 is 5 units. These 2 points are 10 comma 0 and 2 comma 0. Okay, if you read the question carefully, they also have mentioned find the points, find the coordinates of points. Read the question carefully. That means there are 2 points in the x-axis which are at a distance 5 units from the point 6 comma minus 3. Now, you know, many times students are not able to understand that how come there are 2 points. I will show you with the help of uh, Cartesian plane. Although there is no plotting involved in the whole chapter, but I think in this example I have to show you with the example of Cartesian plane. So suppose we have a point 6 comma minus 3. 6 comma minus 3 is a point which is somewhere over here. Okay, so this point is 6 comma minus 3 and this point is P. The distance of 6 comma minus 3 from 2 points on x-axis is 5 units. Which are these 2 points? One is 2 comma 0, which is somewhere over here. Okay, this point is A, 2 comma 0, and the other point, if you extend x-axis in this direction, you will find the other point somewhere over here, B, 10 comma 0. Both these distances AP and BP are same. How much these distances are? 5 units. So we had to find the value of x. That means we had to find both these points, which we found with the help of distance formula. Now you understand. So let's check the method which they have used. They have also used the same method, solving the quadratic equation which I showed you how to solve. They've got the same 2 points. Okay, now I think it must be clear. Okay, next question. Km is a straight line of 13 units. Let me write over here. Km is equal to 13 units. It's a straight line. Okay. K has a coordinate of 2 comma 5 and M has the coordinate of x comma minus 7. find the value of x. Find the value of x. Values of x. They are, see, again, they have a hint also in question that you will not get a single value of x in the answer. You might get two different values of x. Not a problem. We can solve it. Okay, so km is equal to 13 units. K is given, m is given, x is missing. So km, sorry for that, km is equal to under root of 2 minus x the whole square plus 5 minus 7 the whole square. So km is equal to 2 minus x the whole square, that is 2 square minus 2 into x, that is 4x plus x square, plus 5 minus 7, that is 5 plus 7. 5 plus 7 is 12. 12 square. 5 minus 7, sorry, 5 plus 7 is 12 and 12 square is 144. Okay, now km is how much? 13 units. So we'll write 13 is equal to, okay, so here we have x square minus 4x. This is 2 square, which is 4, plus 144, which is 148. So we'll do squaring both the sides. Squaring both sides. What do we get? 13 square, which is 169, is equal to x square minus 4x plus 48. Shall we simplify this? So x square minus 4x plus 48, actually it is 148 minus 169, right? Because 144 plus 4 is 148. 148 minus 169. Okay, so this will be if we had 149, then it would be minus 20. We have 148. Okay, so I think it is minus 19. So x square is equal to 0. X square minus 4x minus 19, I think 21 it should be. Let me check. 169 minus 148. Yes, it is 16 minus 14, 2. It is 21. It is minus 21. Minus 21 is equal to 0. Now let's take out factors of 21. Sorry, minus 21. So factors of minus 21 are 7 threes are, and we want minus 4. So minus 7 plus 3. Minus 7 multiplied by plus 3 is minus 21. Minus 7 plus 3 is minus 4. So x square minus 7x plus 3x minus 21 is equal to 0. That's the method of solving quadratic equation. Let's solve it further. So x bracket x minus 7, I'm taking out common. X plus 3 bracket x minus 7 is equal to 0. So x minus 7 bracket x plus 3 is equal to 0. Therefore, x minus 7 is equal to 0, or x plus 3 is equal to 0. Therefore, x is equal to 7 or x is equal to minus 3. X is equal to 7 or x is equal to minus 3. So this is the value of x. Now what we had to find? We had to find the values of x, and these are the values of x. So the point m could be 7 comma minus 7, or it could be minus 3 comma minus 7. The values of x are 7 or minus 3. Let's check. 7 or minus 3, absolutely correct. Okay, next question. Which point on the y-axis is equidistant from the points 12, 3 and minus 5, 10? Now this point is on y-axis and it is equidistant from these 2 points. Any point on the y-axis is always of the form 0, y. This 0, y is equidistant from 12, minus 3 and minus 5, 12, 10. Okay, let's write our 2 points, 12, minus 3 and minus 5, 10. Let the point on y-axis be 0, y and let it be equidistant from, okay, let this point be P, let it be equidistant from one point Q, which is 12, 3, and another point R, which is minus 5, 10. Let the point on y-axis be 0, y and let it be equidistant from Q and R. So what do you mean by that when point P is equidistant from Q and R? When point P is equidistant from Q and R, that means the distance of P and from Q is equal to the distance of P from R. That means PQ is equal to PR. PQ is equal to PR. Now what is PQ? PQ is under root of, PQ is under root of 0 minus 12 the whole square plus y minus 3 the whole square is equal to under root of PR 0 minus minus 5 the whole square plus y minus 10 the whole square. Squaring both sides. Squaring both sides. What do we have? When we square both the sides, the root gets cut off from both the sides. Okay, so 0 minus 12 is minus 12. Minus 12 square is 144 plus y minus 3 the whole square is y square minus 6y plus 9 is equal to, here also the root gets cut off, 0 minus minus 5 is 5, 5 square is 25 plus y minus 10 the whole square is y square minus 20y plus 100. Okay, so this is what you are getting. Now when you open the bracket, see outside there is plus sign, so nothing is going to change. So you can simply cut this y square. Okay, now let's simplify everything. Let's bring this 20y over here. So this 20y will come here, minus 6y will come here. 144 plus 9. 144 plus 9 is 153 plus 153 is equal to 25 plus 100 is 125. So 20y minus 6y is 14y. 20y minus 6y. 20y minus 6y is 14y is equal to 125 minus 153. Now 125 minus 153 is minus 28. So 14y is equal to minus 28, which implies that y is equal to minus 28 by 14, which is nothing but minus 2. Y is equal to minus 2. Okay, so that's the value of y. What did we have to find? Which point on y-axis is equidistant from this point? Okay, so the final answer which we have to write is, therefore, the point on y-axis is 0, minus 2. 0, minus 2 is a point on y-axis, which is equidistant from Q and R, 12,3 and minus 5,10. Okay. Next is question number 6, in which they are saying use the distance formula to show that the points A, B and C are collinear. Point A is 1 comma minus 1, point B is 6 comma 4, point C is 4 comma 2. They are collinear. Now understand this thing. You will have question like this in exercise also, and the method of solving this question is given over here. 3 points A, B and C are said to be collinear if AB plus BC is equal to AC. That is, B is in between A and C. That's why AB plus BC is equal to AC. Or AB plus AC is equal to BC. That is, A is in between B and C. So BA plus AC is BC. Or AC plus CB is equal to AB. That is, C is in middle and A and B are on the corners. That's why AC plus CB is equal to AB. So if one of these three conditions are true, then the 3 points are said to be collinear. So we have to actually find only, we don't have to do all these things. We just have to find this thing. We have to find AB, we have to find BC, and we have to find AC. If one of these three conditions are fulfilled, then we can say that ABC are collinear or not. Actually, they have asked you to use the distance formula to show that these points are collinear. That means they are collinear. Only thing you have to show it. Okay, so let's write the coordinates. A is 1 comma minus 1, B is 6 comma 4, C is 4 comma 2. 1 minus 1, 6, 4, 4, 2. Okay, so these three are our points. For finding collinearity or for proving collinearity, we have to find the distance AB, then distance BC, and then distance AC. Let's find AB first. AB is equal to under root of, we can easily, now we don't know, we don't want x1, y1, x2, y2, we can easily apply the formula. 1 minus 6 the whole square plus minus 1 minus 4 the whole square, which is under root of 1 minus 6 is minus 5 square is 25, plus minus 1 minus 4 is minus 5 square is 25, so root 50. So this will be 25 twos are and 5 root 2. The value of AB will be 5 root 2 units. What about BC? Okay, BC will be 6 minus 4 the whole square, 6 minus 4 the whole square, plus 4 minus 2 the whole square is equal to 6 minus 4 is 2, 4 minus 2 is also 2, so 2 square is 4 plus 4, that is 4 plus 4 is 8, that is root 8, that is 2 root 2 units. Okay, cool. AC is 1 minus 4 the whole square plus minus 1 minus 2 the whole square, which is 1 minus 4 is minus 3 square is 9, plus minus 1 minus 2 is minus 3 square is 9 again, so it becomes root 18. Root 18 is 9 twos are, so 3 root 2 units. And here it is evident that 2 root 2 plus 3 root 2 is 5 root 2. That is BC plus AC. Here it is evident that BC plus AC is equal to AB. BC plus AC is equal to AB. Right? If BC plus AC is equal to AB, what we can say? Therefore, A and B will be in the corners and C will be in the middle, right? That's why AC is 3 root 2 and BC is 2 root 2 and their sum AB is 5 root 2. Okay, and therefore ABC are collinear. Proved? Let's check. Yes. So that is the way exactly how I did it. Understood? Let's go ahead. Okay, what is the next question? Show that the points A, B, C are the vertices of an isosceles right angle triangle. Very nice question. The points are 8, 3, 0, 9, 14, 11. 8, 3, 0, 9, 14, 11. So we have to show that these 3 points are the vertices of a right isosceles triangle. What is a right isosceles triangle? So we have a triangle ABC, which is a right isosceles triangle. Triangle ABC, which is a right isosceles triangle. So what is the speciality of these two triangles? What is the speciality of this triangle? In this triangle, any two sides are equal. Let's say here AB and BC are equal. We don't know actually which side, so we should not write it. We'll write the names later. So any two sides are equal, and the third side is which is not equal is the hypotenuse. So to prove that it is isosceles, any two sides will be equal. So basically what we have to do is we have to find AB, BC and AC. Out of AB, BC and AC, any two sides will be equal. And the third side will be the hypotenuse. So square sum of the squares of the two smaller sides should be equal to the square of the larger side. If all these three conditions are fulfilled, all these two conditions basically are fulfilled, that is any two sides are equal and the sum of the squares of two smaller sides is equal to the square of the larger side, then we can say that this triangle is a right isosceles triangle. So let's find what is AB. AB is under root of 8 minus 0 the whole square plus 3 minus 9 the whole square, which is 8 minus 0 is 8, 8 square is 64, plus 3 minus 9. 3 minus 9 is minus 6, and minus 6 square is 36. So that is root of 100, which is 10 units. Which is 10 units. AB is 10 units. What about BC? What about BC? So BC is 0 minus 14 plus 9 minus 11 the whole square. Okay, 0 minus 14 the whole square. So 14 square minus 14 square basically is 1 sorry 2 sorry 196. 14 square is 196, I forgot apparently. And 9 minus 11 is minus 2, and minus 2 square is 4. Correct? So this is root of 200, which is 2 into 100, that is 10 root 2 units. And let's finally find AC, which is 8 minus 14 the whole square plus 3 minus 11 the whole square. 8 minus 14 is minus 6. Minus 6 square is 36 plus 3 minus 11 is minus 8 and minus 8 square is 64, which is root of 100, which is 10 units. So here we have AB and AC equal. So this point is A, this is B, and this is C. AB and AC both are how much? 10 units each. And BC is 10 root 2. So it is proved that it is a isosceles triangle. Now we have to prove that it is a right isosceles triangle. That means angle A is 90 degree. That means we have to first find AB square plus AC square. AB square plus AC square is 10 square plus 10 square, which is 100 plus 100, which is 200. And we already know that BC square is equal to 200 because BC is root 200, so BC square is 200. Therefore, AB square plus AC square is equal to BC square. And therefore, triangle ABC is right angled at angle A, okay, and also AB is equal to AC, so it's a right isosceles triangle. It's a right isosceles triangle. Okay, so distance formula is very much useful for doing all this. Now you will tell that there is no coordinate geometry in this. There is a coordinate geometry. There are coordinates. There is a geometry also because geometrical shapes are also there. So coordinate geometry has you can say widespread application. This is just the beginning actually. Next is some facts about a quadrilateral. A given quadrilateral will be a parallelogram if both the pairs of opposite sides are equal. So for proving a quadrilateral to be a parallelogram, you just have to prove that both the pairs of opposite sides are equal. For proving a quadrilateral, a rectangle, you have to prove that both the pairs of opposite sides are equal and diagonals also equal. For proving a quadrilateral rhombus, all the sides must be equal, and proving the quadrilateral a square, all the sides are equal and diagonals are also equal. So while using distance formula, if you have to prove something regarding quadrilaterals, nothing related to angle will help you because distance formula has nothing to do with angles. Like square has all angles equal to 90 degree, but how you can prove that angles are 90 degree? We cannot prove using distance formula only, right? So these things will be sufficient for proving certain quadrilaterals as parallelogram, rectangle, rhombus, or square. Okay, let's do one question based on this. I think it will come ahead. Eighth question is not exactly based on this. What is this question? Find the area of the circle whose center is 5 comma minus 3 and which passes through the point minus 7 comma 2, and we have to take pi as 3.14. They have suggested beforehand. Okay, find the area of the circle whose center is 5 comma minus 3 and passes through the point minus 7 comma 2. 5 comma minus 3 minus 7 comma 2. Let's do it over here. Center 5 comma minus 3 and passes through the point minus 7 comma 2. Let's check it once. 5 comma minus 3 and minus 7 comma 2. So it is somewhat like this. This is the center and this is the point. This center is O and this point is P. P is minus 7 comma 2 and O is 5 comma minus 3. O is 5 comma minus 3 and P is minus 7 comma 2. We have to find the area of this circle, and for finding area we have to find the radius. Radius is the distance between O and P, correct? Let's find OP. OP is under root of 5 minus minus 7 the whole square plus minus 3 minus 2 the whole square. So OP is equal to 5 plus 7, that is 12 the whole square, that's 144, plus minus 5 the whole square, which is 25. So OP is equal to under root of 169, which is 13 units. So we have got OP, which is the radius. So area is equal to pi r square. Pi is 3.14 multiplied by 13 square. So 3.14 multiplied by 169. Please find the area in whatever you will get, whatever answer you will get, it will be in square units. Okay, because area is always in square units. So don't forget to write that. Please pause the video and do the calculation. Very easy, right? Very easy applications of distance formula. This is a very small chapter. Now I don't understand that why this chapter was not done in your school earlier. Okay, I think you all have got the answer. Let's check. Yes, so it should be 530.66 square units. 530.66 square units. Okay. Next is question number 9. Find the points on x-axis whose distance from the points A and B are in the ratio 1:2. Okay, again, remember that you have to find points, coordinates of the points. So there can be more than one point. So there are 2 points. Let's consider on the x-axis. There are 2 points on x-axis. You consider a point on x-axis to be 0, sorry, x comma 0, and then begin. Okay, whose distances from the points A and B are in the ratio 1:2. Okay, so let's write the details. A is 7,6, B is minus 3,4. 7,6 minus 3,4. Okay, these are the 2 points, and the distances of these 2 points from a point on x-axis. Let a point on x-axis be x comma, okay, I will take this point as C. Let me take this point as P, x comma 0. That is, the point on x-axis is P. So what they are saying as the distance of these 2 points from this point P is in the ratio 1:2. That means AP is to PB is equal to 1:2. Or we can write AP upon PB is equal to 1/2. What is AP? Under root of 7 minus x the whole square plus 6 minus 0 the whole square, the whole upon under root of PB or BP. So we'll write minus 3 minus x the whole square plus 4 minus 0 the whole square. This is AP upon PB or BP is equal to 1/2. Okay, so this will become, see, before I do anything, I just want to get rid of this roots. So I will write squaring both the sides. We will get 7 minus x the whole square plus 6 square the whole upon minus 3 minus x the whole square. Now minus 3 minus x the whole square, can I write it as minus of 3 minus x the whole square? So minus sign will automatically get cut. So it is nothing but 3 plus x the whole square. Minus 3 minus x the whole square or 3 plus x the whole square. Anyways, you are squaring both the sides. So if you take out minus and then square it, right, the minus sign gets cancelled anyway. Plus 4 minus 0 the whole square, that is plus 4 square, is equal to 1/4. Okay, so 7 minus x the whole square is 49 minus 14x plus 49 minus 14x plus x square plus 36 the whole upon 3 threes are 9 plus 6x plus x square plus 16 is equal to 1 by 4. Let's first simplify and then write it properly. So x square minus 14x. So 36 plus 49 will be equal to 85 because 36 plus 50 is 86. So yeah, plus 85 the whole upon x square plus 6x plus 25 is equal to 1 by 4. Okay, let's cross multiply this. So 4 bracket x square minus 14x plus 85 is equal to 1 bracket x square plus 6x plus 25. So 4x square minus 56x plus 85 fours are. So 85 twos are is 170 and 170 twos are is 340 is equal to x square plus 6x plus 25. So 4x square minus x square minus 56x minus 6x plus 340 minus 25 is equal to 0. So 4x square minus x square is 3x square. Minus 56 minus 6 is minus 62 x and 340 minus 25. Let me check this once because I think this is a big numbers which we are getting, but still I think it is correct. We did not make any mistakes, but still I have to check maybe some coordinates here and there. So 340 minus 25 is 315. So can I take out some anything common from here? No, nothing can be taken out common because 62 is not a factor of 3. Let me check. Okay, I checked the whole thing and it is absolutely correct. So we are going right and we have to do splitting the middle term of this huge thing over here. Okay, so let's see what do we get. 315 multiplied by 3. So this will be 945. 315 multiplied by 3 is 945. And if we take out the factors of 945, let's do the factorization. So 315s are 3105s are 335s are 5 335s are right, 3 threes are 9, 1 3 5s are 15, correct, 5 sevens are and 7 ones are. So these are the factors and we want minus 62 as the sum or difference of any two numbers which will come out from these factors. Okay, so let's see what we are getting. 62, 3 threes are 9, threes are 27 and 35. 27 plus 35, 27 plus 27 plus 35, 5 plus 7 12, and here we are getting 6. Yes, so we got 27 plus 35. 27 plus 35 is 62. So 945 will be split into 27 and 35 in such a way that both of these will be minus and we will get plus 945 and minus 27 multiplied by minus 35 is plus 945 and minus 27 minus 35 is minus 62. So 3x square minus 27x minus 35x plus 315 is equal to 0. Okay, so here we'll get 3x inside x will remain minus 9. Okay, here minus 35 will come out common and x minus 9 will remain, because 35 nines is 315. Okay, so we are going to get 3x minus 35 and x minus 9 equal to 0. Therefore 3x minus 35 equals to 0, and comma, or sorry, x minus 9 is equal to 0. Okay, let me just remove this. I hope you have noted it down. If not, then rewind and note it down. So 3x is equal to 35 or x is equal to 9. X is equal to 35 by 3 or x is equal to 9. X is equal to 35 by 3 or x is equal to 9. Great, 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 great. So what now? Hmm what did we want? We started from here, right? Yeah, so we wanted to find the point on x-axis and we have got two values of x. So final statement would be, therefore the 2 points on x-axis are 35 by 3 comma 0 and 9 comma 0. The 2 points on x-axis are 35 by 3 comma 0 and 9 comma 0. Both these points, okay, if you take any one of these 2 points, the ratio of the distances of these any one of these 2 points with a and b will be 1 is to 2. Okay, 35 by 3 comma 0 and 9 comma 0. Let's check the answer. 35 by 3 comma 0 and 9 comma 0. Okay, so this is how you solve it. Now see, there are many instances where you are coming across quadratic equation. This was one and this was a big one, and then there was question number, I think this here, no, not here, question number 4 and question number 3. So there are many instances where you are coming across quadratic equations, solving quadratic equations. Okay, you have factorized quadratic equation in the chapter factorization, but you have not solved it. You have not find the value of x. In this chapter you are doing that. So that is one skill which you have learned in this chapter. So please uh, focus on that skill and learn it properly. Okay, you will have to use it in the exercise as well. Okay, the next topic and the last question of the chapter, we are actually at the end of the chapter. So the next topic is circumcenter of a triangle. Circumcenter of a triangle. Now I told you about regarding circumcenter before starting the chapter congruency, if you remember chapter congruency. So circumcenter, what is circumcenter? Circumcenter is the point which is equidistant from all the vertices of a triangle. So if suppose P is the circumcenter of triangle ABC, then PA, PB and PC all are equal to each other and they are known as circumradius. So if you take P as center and if you take PA, PB or PC as radius and draw a circle, that circle will be called circumcircle. That circle will be called circumcircle. Circumcircle is a circle which passes through all the three vertices of a triangle. Okay, so this part is about the circumcenter, the center of such a circle, or the point which is equidistant, point which is inside the triangle and equidistant from all the three vertices. Okay, so uh, we will find the coordinates of circumcenter. Okay, let's do this question. Find the coordinates of the circumcenter of triangle ABC whose vertices A, B and C are 4, 6, 0, 4 and the C vertex C is 6, 2. 4, 6, 0, 4 and 6, 2. Find the coordinates of the circumcenter of triangle ABC. Okay, so let's start. Let's first write that. Let the coordinates let the coordinates of circumcenter be P bracket x comma y. Let the coordinates of circumcenter be P bracket x comma y. We don't know any coordinate of the circumcenter, so we have to find two missing values, which is x and y. Correct? Only information we have, since P is the circumcenter, since P is the circumcenter, PA is equal to PB is equal to PC. PA is equal to PB is equal to PC. Okay. So what is PA? Therefore, PA is equal to, let's first find PA, then PB, then PC. Okay, then we'll see what we get. PA is equal to under root of x minus 4 the whole square plus uh, y minus 6 the whole square. X minus 4 the whole square plus y minus 6 the whole square. This is PA. Okay. Similarly, PB will be equal to x minus 0 the whole square plus y minus 4 the whole square. Okay. And PC would be equal to under root of x minus 6 the whole square plus y minus 2 the whole square. Okay, so since we know that PA is equal to PB is equal to PC, we can say that let's take PA is equal to PB. So it implies that under root of x minus 4 the whole square plus y minus 6 the whole square is equal to under root of PB, that is x minus 0 the whole square or x square plus y minus 4 the whole square. Okay, so immediately in the next step I'm going to do squaring both the sides, so I'm going to simplify this. So I'm just going to be left with x minus 4 the whole square plus y minus 6 the whole square is equal to x square plus y minus 4 the whole square. Okay, x minus 4 the whole square will be equal to x square minus 8x plus 16 plus y square minus 12y plus 36 is equal to x square plus y square minus 8y plus 16. We are just going to simply cut x square, y square from both the sides. So we are going to get minus 8x minus 12y plus 8y. See, I just brought 8y to the other side. Okay, is equal to 16. Acha, 16 would cut from both the side right away, and we'll be left with just one number over here. See, minus 8x I've written, minus 12y I've written, minus 8y I brought to from the other side, became plus 8y, plus 36 I'm just going to bring it to the other side, so it will become minus 36. So this will be minus 8x minus 4y is equal to minus 36. Let's simplify this further. This could be simplified. So this will become minus 4 will come out common. So 2x minus y is equal to minus 36. Minus minus gets cut. So 2x minus y is equal to 36 by 4, which is 9. This is equation number 1. Keep it as it is, because This is simultaneous linear equation in two variable, and you are going to get one more such equation, okay, which will be solved and simplified further. Okay, so I equated PA and PB. Now let me equate PB and PC. Okay, let's see. So PB is equal to PC is given, so which implies that, sorry, PB is under root of PB is under root of x minus 0 the whole square plus y minus 4 the whole square. That is x square plus y minus 4 the whole square, right? I'll directly write x square plus y minus 4 the whole square, because I already know what PB is equal to under root of PC. PC is x minus 6 the whole square plus y minus 2 the whole square. X minus 6 the whole square plus y minus 2 the whole square. Okay, now squaring both the side comes naturally. So we do squaring both the side and we'll be left with x square plus y square minus 8y plus 16 is equal to, we'll just open the bracket. So x square minus 12y plus 36 plus y square minus 4y plus 4, y square plus 4y minus, sorry, y square minus 4y plus 4. So x square would cut y square would cut. Anything else? I don't see anything else. Is there a term with x? Yes, there is a term with x. Why did I write y over here? This is minus 12x. See? So I'll bring minus 12x to this side and this will become 12x. Minus 8y is already over here. I'll bring minus 4y here, so it will become plus 4y is equal to 36 plus 4 is already here, and I'll bring 16 over that side, so this will become minus 16, right? So how many terms in all? 1 2 3 4 5 6. I'm counting the terms because I should know that I'm not missing anything. 1 2 3 4 5 6. Okay, perfect. So 12x minus 8y plus 4y is minus 4y is equal to 36 plus 4 is 40, and 40 minus 16 is 24. Okay, so let's take out 4 common, so it will be 3x minus y is equal to 24, which will be 3x minus y is equal to 6. Equation number 2, 3x minus y is equal to 6. 3x minus y is equal to 6. Great. So what have we got? See, we wanted the coordinates of point P. Have we got coordinates of point P? No, we have got two equations. Let's solve these two equations and then we'll get the coordinates of point P. Okay, so solving equations 1 and 2. How we will solve it? Let's subtract these two equations. Okay, so 2x minus y is equal to 9 minus 3x minus y is equal to 6. I'm sure you know by which method I'm solving. I'm solving with the method of equating coefficients. Elimination by equating coefficients. The coefficients of y are already equal, but their signs are same, so that's why I'm subtracting. Here there will be minus sign, here plus sign, and this will be minus. So 2x minus 3x will be minus x, minus y plus y will cancel, and 9 minus 6 will be 3. So x is equal to minus 3. Now substituting x is equal to minus 3 in equation 1. So we have 2 bracket minus 3, that is 2x, minus y is equal to 9. So minus 6 minus y is equal to 9, or minus 6 minus 9 is equal to y. That means That means y is equal to 15. Y is equal to 15. So y is 15 and x is minus 3. Therefore, the coordinates of circumcenter are minus 3 comma 15. Let's check the answer. This was a good question. Okay, so the answer is wrong. Apparently, the answer is 3 and 3, 3 comma 3. The two equations which they have got are 2x plus y is equal to 9. Let me check the first equation. 2x minus y is equal to 9. How come we have got, oh my god, see the silly mistake over here. See, this they have taken out, I have taken out minus 4 and I've still kept minus sign inside. So this will be plus and this will be plus. Okay, so I think, what about the second equation? 3x minus y is equal to 6. Let's check the second equation. They have done PA is equal to PC, so I doubt that second equation will match with me. But my first equation was definitely wrong. 2x plus y is equal to 9. Okay, let me just solve it all over again. I'm sorry for that, this mess which I have created. Uh, the whole thing I have to let go. See, sometimes these things happen. I'm sure it happens with you also. But it's okay. We have to learn and we have to move forward. Okay, so how we'll solve equation 1 and 2? See, equation 1 is 2x plus y is equal to 9. And equation 2, it looks correct to me. Equation 2 is 3x minus y is equal to 6. 3x minus y is equal to 6. So if you add these two equations, what you'll get? 5x is equal to 15 and x is equal to 15 by 5, which is 3. X is equal to 3. Correct? Now, sorry for this mess. Let me just let go of these two. Okay. Substituting x is equal to 3 in equation 1. What is equation 1? 2x plus y is equal to 9. So 2 bracket 3 plus y is equal to 9. That is 6 plus y is equal to 9. That is y is equal to 9 minus 6. So y is equal to 3. So x is 3 and y is also 3. Okay, corrected my mistake, found the mistake and corrected it. Okay, so there is just one simple exercise, 28 questions in it. The chapter is over very quickly. I hope you like this chapter and very easy chapter. See you in the next video. Bye bye.